So this is my chapter 4 exam for my physics 1 class, and I had question 1, and it says calculate the magnitude of the total resultant force Ft equals F1 plus F2 plus F3 acting on the mass. So for F1, that equals, F1 is, so it's right here, so that's 25, so it's 4. So I would do 4 cosine 25 degrees x plus 4 sine 25 degrees y is all gonna be in newtons. And then F2 equals, it's 325 is F2. So, and that's gonna be 6. So what I would do is 6 cosine 25 degrees x plus 6 sine, not 25, I'm sorry, 325 degrees x plus 6 sine 325 y. It's newtons again, and then for F3, it's gonna be 180, and then you would do, and it's 8, so you would do 8 cosine 180 degrees x plus 8 sine 180 y newtons. Then you have to do Ft equals F1 plus F2 plus F3. So what I would do is, well, let me just write Ft equals F1 plus F2 plus F3, and that equals, we would do 4 cosine 25 degrees plus 6 cosine 325 degrees plus 8 cosine 180. You just, what I'm doing is putting the cosine with the cosine and the sine with the sine, and then do plus 4 sine 25 degrees plus 6 cosine 325 degrees plus, not cosine, I'm so sorry, 6 sine plus 325 plus 8 sine 180. And then you get, for that, this cosine is 0.540, and then minus 1.751 for the y. Then you gotta take the square root. So you would do 0.540 squared plus minus 1.751 squared, which equals 1.832 newtons, or you could just say 1.83. And then for 1b, it says, what angle does Ft make with the positive x-axis? So for part B, I would just do tan theta equals negative 1.751 divided by 0.54. Then you have to get theta by itself. So theta equals tan minus 1, and then negative 1.751 over 0.54, which equals negative 72.86 degrees. And then you could just round out to negative 73 degrees. And then for 1c, it says, what is the magnitude of the max acceleration vector A? So for vector C, you have to use Newton's second law. So I would just do Ft equals ma. But Newton's second law is F equals mass times acceleration And then to put it, you need to find A. So A needs to be by itself. So A equals Ft over M. And the given mass is 2 kilograms. So I would plug 2 in. So I would do A equals 1/2. In parentheses 0.540 minus 1.751. Then you have to divide them by 2. So you would get 0.27 minus 0.8755. And then you gotta do the square root for this. So I'll just do it right here. The square root. So you have 0.27 squared plus negative 0.8755 squared, and that equals 0.916, but you can round that to 0.92 meters per second squared. And then for part D, so you can just see how it looks. I'll circle it for you so you can see the answer properly. And then for part D, it says, what is the direction of A? In other words, what angle does this vector make with respect to the positive x-axis? So what I would just do would be the same thing I did for 1b, the tangent theta equals that. So I would just do, but with different numbers now. So tangent theta equals negative 0.8755 over 0.27. I gotta get theta by itself. So I would just subtract the tangent. So theta equals tangent minus 1, and then negative 0.8755 over 0.27, which equals negative 72.86 degrees, which you can round it to negative 73 degrees, like that. 73. I know it's a little small in the corner. And then for E, it says, how far in meters will the mass move in 5 seconds? So the initial velocity, so I'm just gonna put V0 equals 0. And then the acceleration equals 0.92. And the time equals 5 seconds. And then the formula I would use would be S equals U plus UT plus 1/2 AT squared. And now I'll plug the numbers in, and I'll do, so you can see it. Now I'll plug the numbers in. So it'll be S equals 0 plus 0.5 times 0.92 times 25. And then you get 11.45. And then you could just round it to 11 meters. Like that. And then for part F, it says, what is the magnitude of the velocity vector of the block at t equals 5 seconds? So I would just do, they're asking for velocity, so I would just do, well, let me just write it down, 1e equals, so I would just do v equals a times t. So I'll just plug in the numbers. So I would just do 0.8755 0.92 times 5, which equals 4.6 meters per second. So, and then you can see how I did it here. And then it says part G, in which direction is the mass moving at time t equals 5 seconds? That is, what angle does the velocity vector make with respect to the positive x axis? So I would do, so I know I would have to do F net equals m dv over dt, and then I would plug in those numbers. So 0.54 again, or 0.54, 0.14, because it's like the rest. Or I'll just do 0.54 minus 1.751, and then that equals 2 du over dt. And then I have to divide these two by 2, and then I would get 0.027 minus 0.87555. Now I have to multiply these by 5 because it's asking me what is the mass moving at t equals 5 seconds. And then I get now, and then I would get now times 5. I'll just put it here so you can see. And then now I would get v equals 1.35035 minus 4.37745. It'll be meters per second. And then now I would do like how I did for 1b and 1d, the tangent theta equals negative 4.37745 divided by 1.35035, which equals theta equals 287.144 degrees. And you can round that to 290 degrees. Just like that. And that's what I had got for part G. And you can see for the rest of them I got for part F was 4.6, then E was 11, D was negative 73, part C was 0.92, part B was negative 73 degrees, and part A was 0.83 newtons.